In absence of a net external force, objects remain at rest or in uniform linear motion with constant velocity. This is what we learn in Newton's first law of motion. But what about when there is a net external force? Net external force creates a change in velocity, and as per definition, rate of change in velocity is the acceleration. So indirectly, first law tells us that the effect of net external force is acceleration. But it don't talk about the quantitative relation between force and acceleration. It don't tell what will be the acceleration of an object when there is a net external force. Newton's second law of motion established the relation between net external force and its effect on object motion. Force effect on object motion can be seen in form of its velocity change, or more precisely in form of change in object linear momentum. What is this linear momentum and how it is related to applied force? Linear momentum is defined as P equal to mv, where m is the mass of the object and a scalar quantity, and v is the velocity and a vector quantity. So we can say that p is a scaled vector of v. That means p's magnitude is m times of v's magnitude and has same direction as v. As per Newton's second law of motion, the rate of change of momentum of an object is directly proportional to the force applied. Here, the k is constant of proportionality and its value is 1 for SI units. So, higher the rate of change in momentum, higher the force, and vice versa. For example, in cricket, when a cricketer catches a ball, he pulls back his hand and gives sufficient time to stop the ball. This lowers the rate of change in ball's momentum and hence feel less impact or force. Similarly, airbags in car at the time of accidents inflate and increase the time of a stop of passenger's body and thus lower the rate of change in momentum and in turn lower the impact or force on body and less fatal. As P is equal to mv, so F can be written in the form of m and v. When m is a constant, you can write down force is equal to m dv by dt, which is equivalent to mass into acceleration. So acceleration can be written as force divided by mass of the object. So in other words, as per Newton's second law of motion, the acceleration of an object is given by the vector sum of forces, means net external force acting on that object divided by its mass. Here, acceleration A is directly proportional to the force or inversely proportional to the object's mass or inertia. A block of 1 kilogram pushed by a force of 10 Newton will have acceleration of 10 meter per second square. While the same block is pushed by 20 Newton, then its acceleration will be 20 meter per second square, the double of what we have in first case. In another scenario, when the mass of the block is doubled, keeping the force same, its acceleration reduced to half. This shows that the acceleration is inversely proportional to the mass of the object. Till now, we're talking about the external forces. But do you know how to identify the external force and their net effect on the system? To identify the external force, we need to first define the boundary of the system of interest. There are 3 blocks connected with ropes and pulled in positive x direction with force 28 Newton and accelerating with acceleration a. Here, let's assume 3 blocks inside our system of interest. All the forces which interact to the system through this boundary are external forces. As a next step, assume this system as a point mass at its center of mass and apply all the forces there, assuming ground is frictionless. There are three forces in this case on the system. Force F in horizontal direction, the gravitational force in downward direction, and the normal force because of the ground surface in upward direction. So we have identified our system and all the external forces. Now we need to find out the net force on this system and its motion effect. So how to find the net external force on the system? As the force is a vector quantity, so net force is found by the vector sum of these forces. Using graphical method or by analytical method, resolving them into components. For detailed methods on vector addition, please check out our videos listed in description box below. In summary, the net external force is the vector sum of all external forces working on the system, and it works at the center of mass of the system. Because of that, the system accelerates and its acceleration is given by F divided by m. Now let's apply Newton's second law of motion in about 3 block example with different system boundaries. Meanwhile, I hope you would be enjoying this session. If you think you are learning something new today, then please click like button and subscribe us for similar type of videos on physics. This help and motivate us to bring new videos for you every week. Here, let's consider these 3 blocks as a system. These 3 blocks combined together has 7 kg of mass and is being pulled by a tension force of 28 Newton. The system is under gravitational force working as a weight of the system in downward direction and a normal reaction force because of the ground surface in upward direction. Now let's analyze these forces. For vertical forces, here W, the weight of the system, works in downward direction and there is an equal and opposite normal reaction force by the ground on the system. So in vertical direction, the net force is 0. So there is no motion in vertical direction. Now what about the horizontal direction? In horizontal direction, the mass of 7 kg, the total mass of these 3 blocks, is pulled by a tension force of 28 Newton. And because of that, the acceleration of the system is A. So here A can be found out by Newton's second law of motion, which is equal to 4 meter per second square. Now let's check about where our system of interest covers only 2 blocks. The block of 1 kg and 2 kg. In horizontal direction, the mass of the system is 3 kg, which is pulled by a tension force of T2, and the acceleration of this system is same as the complete system, 4 meter per second square. So we can find out the tension T2 using the Newton's second law of motion. So here it is 12 Newton. What about the vertical forces? The vertical forces are balanced and there is no motion in vertical direction. Now let's consider a system of one block of 1 kg. In horizontal direction, there are 1 kg of mass is pulled by tension force T1 with acceleration A equal to 4 meter per second square. Remember, this acceleration of 4 meter per second square we calculated in the first case itself when we consider all the 3 blocks as a system. So acceleration of all these 3 blocks remains same because these blocks are tied together with a stressed rope. So here the tension T can be again calculated using the second law of motion. What about the vertical forces? So vertical forces here again balanced and there is no motion in vertical direction. And that's all we have for today's session. I hope you would have enjoyed it. See you next time. Till then, bye.